All right, so everyone wants to know about this Turkey earthquake. A few people have written me. I just want to bring it to your attention. It's just a bunch of concrete buildings that lost their foundations, and foundation being columns, supports, in multiple places in the structure and collapsing. All right, it's as simple as that. There's nothing really profound besides it being an earthquake zone and the concrete buildings and steel would last better. But let me segue into this. So I'm going to segue into this video here. You can see the title of it already. This is a shake table. This shake table is shaking a building that's structurally a model that's structurally a scaled model that's structurally pretty different. Now watch. We're going to come right here. And what I'm going to already cut to the chase and tell you that when you see these abutments like this, even with a gap, that creates when the building rattles, this acts as a shear wall, these two sides. So the building shifts this way and that way. This section here can't do the movement with it. It can't shift with it. It doesn't have the flexibility. This wall has reinforcement, let's say like that. This reinforcement is here, and then it has a dead load on top of it to keep it more stationary. There's no dead load on top of this one. So they're going to shake it, let's say west and east, and we're going in multiple, little rotation on it too, but this is the problem with that connection in this case. I'll see it repeatedly when I see connections like this, looking at my shake table failures. Let's watch it. Okay, I don't know if some of you saw it, but you saw this thing. If you saw it, you saw this whack to the left and whack to the right. Torque resolving itself like that. I'll slow it down and back it up. So let's do that. Press play. All right, let's slow it down here. I'll do a quarter speed and let you observe the wobble effect. And so this is what's happening with these structures. Depending on how these walls are set up, so each building will have its own story on what made it initially buckle and collapse. This story is one of the many shear walls that are there. How their intent is not to be a shear wall, but like CTS, when I said we'll talk about that wall in the ramp area, how it had played its effect on the structure. Well, that ramp area has this going on also. The ramp area over there at the CTS. Some of you know what I'm talking about. Some of you will have no idea. Put it in the comments for people. Maybe the new people might catch on. But I was informed by the Tube not to do those videos anymore. I got inside scoop from somebody. It's from there. They got hold of me, and I got hold of them, and we got to telling each other off, and finally he came clean. It's sort of like this time that I had a AT&T phone, and it was like $100 a month for unlimited phone calls, unlimited everything on it. That was really expensive, right? Everybody else is paying $75. I paid $100. Roaming, everything free. It was great. And then all of a sudden, everybody else started getting the same thing, but they had to pay like $1.40. Next thing you know, my text messaging is acting up. I'm trying to get it resolved with every technician they have there. Over the period of weeks, it's acting up again. No, that's working great. Now it's acting up again. So one day somebody tells me, look, I can probably get fired for this. But there are notes in here that says, convince him to change his plan. And they were all, because that's the one thing they all had in common. They all kept telling me, you should change your plan. I'm like, what plan do you have? Well, for $140, you can get this, this, and this. And I'm like, wait a minute, I've got to limit it right now for $100. Why would I want to do $40 more? Well, you know, it's just, it gives you a newer plan. It was the weirdest sales pitch ever, you know, trying to convince somebody to go from 100 to 140. And over many weeks. And then finally, this person tells me, look, I can get in trouble. I can tell you now, I'm looking at notes that say, talk him into a new plan. So with that, it was theorized between the two of us, you know, just winking, that, yeah, they sabotaged my plan, that it's going to automatically keep acting up until I finally give up. I mean, they had separate notes in there for that. So that's AT&T. And immediately I left them the next day. I went and found another carrier. So they're not above it. So what I found out with this one is my YouTube channel has been written off the way they did it. Being tactful here is spam. They've written me off as spam to do the controlling. So spam, we don't have to advertise your stuff. We don't really show it. We put you with dog shit. All right, that's one of the videos thing there. So he sort of told me that, because I told him I'm dumping the channel, I'm done, I'm gonna delete everything. After he was getting smart with me. We had quite a few words to say to each other, and I said, don't hold back. I said, I'm not soft. And sure enough, I think it was a guy's name, and we went back and forth, and finally he was like, look, you know, basically he was telling me, here's a wink. And he went about the long way, but when he was done, I was like, got it. I understand what you're saying now. And it came to my form of shadow banning is spam. He said that they don't do shadow banning, and he's trying to make it clear to me. But once we did this long hour plus back and forth writing, it finally hit me when he was saying what he was trying to say. You know, like, what would you consider a toaster in a toaster? You know, whatever. You know, it was some banter like that revealed that I'm throwing in spam. So he told me to basically I got to throw away CTS. Just stop. It's not going anywhere. I mean, it was though that one he was pretty clear. You're not going to get out of it. Just like that person told me about the cell phone. That look, you're beating your head against the wall and getting in trouble for this. It says talk you into another carrier. I mean, talk you into another service. That they're not going to fix it. This guy told me, you're done. On that CTS thing, you're not going to get out. They're not, you know, per what he's looking at, you're not going to get out. First you start off, well, we'll fix everything, we'll fix it. And then it changed to, you know, to instant, like cold shoulder, like he read the notes. Instant, like, you know, you're crazy. And then I basically called him crazy, you know, and we were telling each other off. No, you can't talk to me that way. It was telling each other off. And that made that bond where he finally said, you know, where it came down to, you're not getting out of this. It's done. It's done. And from what he further added to me, it's marked up as spam is how they do it. They don't do it the way I may think they do it, but they have other techniques, which is saying call it spam. So, yeah. And so that falls under spam, and it will not get projected. Now, I told him, I said, well, you need to go ahead and block my short videos, too. I had a couple of shorts on that. And that's what made him have the little bit of humor, too. Plus, I told him, I said, just delete the fucking channel, I told him. Let's go ahead and just delete this thing. And that's when he's like, no, don't give up. He said, change the subjects. And he was the one that said, do one on the earthquake. And so that's where we are now. So I was going to do, you know, a few people asked me, I was going to do it, but I was doing the shake table one way before that because I wanted to show you how it behaved with the CTS, the interlocking, this interlocking. Now I want you to think of the small interlocking down below, the slabs, and you get what's going on. I'm going to show you another video. I have to find it, but Let's run with this. So you can see how stationary it is at the bottom. At this point, the rattling happens, but we don't have anything to keep this together anymore. So the reinforcement steel that goes up, it's lost its connection, its bond with the concrete being buckled like that. So that's where it looks like your flexing now changes from initially that one little flex to now the smaller rock and more deterioration at the one point. Play. So this is a little bit of smaller rock, and there you go. There's your stirrup from there. There's your stirrup right here. That's the stirrup. It looks like it's with the test of the stop. And with that said, you can see how you can observe how it's still standing. Oh, that's Gray Cat scream. Let me pause it and go see what she's doing. So here from this angle, you can see how narrow that wall is. Look how dramatic it is. And there's the stirrup. And it's interesting, you can see the rest of the structure still doesn't look like it did anything down there. A good mid-span took the racking. Now this is an outside piece. Corner. So what would you predict? What would you predict based on what you showed you? Well, just give it much like the camera, but it wasn't the same plane right there. Just mess with the camera a bit. I think we come back in. There we go. So. Remember, this acts like a shear wall. This guy. Boom. Oh, and the compression in there. Banging against it. It's impacting it. It's leaning away. Impact. I don't know if it's the same corner or not. I saw a fracture the other one. Alright, now we're going to look at the two of them together. So just looking at these, it looks like that's the plate. Oh, here's the plate up here. Look at that plate. Alright, so you get a good interlock. Now here's the problem with these tests. The problem with these tests are that they are using newly constructed concrete. And often these buildings are very old, as you know, and they don't behave like this. They won't take the racking like this. They're very old, it's brittle, it's got all this flexion and structural thing going on for years. See that whole panel like is one? Talking about this panel here, I don't know how the rebar is in because it would be nice to expose it. But they might have even, like to make this a shear panel of a type, it's rebar like this. And then they fill it in, they fill this panel in with concrete. And this all ties together. That's one of the forms of earthquake proofing a structure. This is behaving pretty rock solid right yet. I don't remember seeing all of this. Let's see. I'm looking for separation at the edges here, anywhere, and I'm not seeing that. Oh, so they like putting furniture in there to watch the furniture slide. See what happens. The occupants, and you will get thrown in this kind of stuff. You will get thrown off your feet. So let me get you one more video that I think I really want to show you. Let me see if I can fast forward this. Fast forward. Nothing there. Okay, let's move on. Now you remember in CTS where people show this, the material flying at them. Well, think about up here what you're going to see in a second. Let's do it again. so let's go ahead and get you something else to add to this. So I want to show you this video here. It's 1 minute long. This is their version of NIST. This is Japan.
Japanese researchers conducted an earthquake simulation on a 10-story concrete structure.
Now keep in mind, this is 10-story concrete structure, scaled down to about 27 meters or something like that, I recall. You'll tell you in a second. And this is concrete, so 10 stories. Remember, CTS was 12. Some part of it was 11. The other part, the other side of the building. And this is a shake table. Now let's look at and they've got sensors all in there, and they got little models they put in there and steps and everything. But so plate slab construction, think about that. Let me already slam that, but well, no, I'll wait. Plate slab construction, right? Let's just say that first, and then I'll take it back in a second. So here are your columns. This is plate slab construction. Now listen to what it says.
From the 11th of December, with the aim of improving earthquake management strategies. At 27.4.
27.4. Oh, wait a minute. It's not plate slab construction because, as you see here, there are beams they put between each floor. Here's a slab part. This little thin part is a slab part. And then there's the beam. So there's two-way slabs, depending on how they reinforced it. There's two-way slab system everywhere. I don't know how its support goes across I don't know the reinforcement. But if we can look here, look under here, you'll see it's more like a waffle slab construction. So it looks like this. And there's one waffle here, and there's a waffle here. There's everywhere. Same thing on the second floor in that other building, what I'm not supposed to name, STC. How about that? I said it backwards. And this could behave like a two-way slab system. It'd be very nice to have this like that, and then two-way slab on this side, making them independent. That would be nice. You know, that means this could fail here. Some torque rotation would be created on that if it did happen to fail. But it makes it, independent zones. Now, if they just did that and did this, and then they just ran reinforcement all the way across, they're not independent anymore. Sag on this side, pulls on this side. Yes, the beam's in there, and you get some hogging, a little bit of hogging there as it comes back down profile-wise. Here's the beam. But if you get sagging on each side. But that's not concern here because they didn't put any dead loads on these floors. They just put floors. All right, so yes, they're shaking a floor system, but no weights are on it. No human weight, no dead loads, refrigerators, things like that. Heavy industrial equipment that might be on one of the floors. I don't even know what the intent of this building is. Nevertheless, it's 10 stories, they say, and looks mostly open. It looks like an elevator shaft that they put here. All right, so, and stairwell right next to it. So here's a stairwell, all the way up. So, and the outside wall, this further wall out, this wall is noteworthy. It's 2 columns there, and then panel. And the columns all appear to be the same dimensions, whether it's on the corner or not. I don't know how they did the anchor, if they tied down, if they use special. This is Japan, if they're using special anchorage in here or not. They just show the short video. But I want to show you the difference in the behavior of this 10-story compared to what you see collapsing now. This is much more robust, obviously. And it's also new concrete. And extrapolations to this, to current day, doesn't work. This is new concrete. It's at the top of its game of its pour. They probably let 28 days. They tested, and each one was done with, a lab test in mind. So this is not typical of construction. But let's go ahead and play it.
5 meters high. It's the tallest concrete building ever to be tested in an earthquake simulation.
Oh, there it is. You can see it better now. So there's the slabs, the boxes I told you about. I don't know what the intent of that is, but it'll be nice. Let's see if it. I don't know what the intent of that is. Its spans are very short. It's got some nice stocky spans on it. Sometimes they can work against you, but here's again, here's the destruction. So all this, you would ideally hope it acts like a gusset plate how it's anchored. If this can act as a gusset plate, depending on your anchorage of your steel going across and up and all the way down. To have it so it's more rigid. You can have it more flexible too if you could have a way where it would stay together. But more rigid is the anchorage. It's the way to go. So it's not whipping. You don't want it to whip its tail being the top of the building. You think of that, and you can even, as you saw in the other one, the tail is here, and you wag the dog, you wag this part, the lower part, and the tail whips up to the top. If you can have it where it's when you try to push on the bottom, it doesn't move the top. That's great. The least movement, counterweights and all. So they really did a nice job. Motley, you know, they did the real bending of the steel for the lighting. They did that. It's nice to see if we can see it buckle or not.
Researchers at the National Research Institute for Earth Science and Disaster Prevention,
And they really rocked that thing. It's got a circular motion.
said they used the largest shake table in Japan, measuring 15 by 20 meters, to subject.
This was interesting. This little cutout they did. A little cutout. It's a little. I'm just looking at it here with the sensors everywhere. But let's let it go.
The building to the equivalent of a 7.3 magnitude earthquake.
7.3.
The 1,000-ton structure shook violently, but remained standing, with the fourth floor sustaining the greatest amount of damage.
They said with the fourth floor, getting this greatest amount of damage right here. So it appears that's the one that, remember how like the shear wall deal, where it fractured the most. Well, it appears that they got more rigidity out of here, out of that zone there, and then rigidity out of this zone. And the fourth floor is the one that acted like the columns on the first floor, the other structure we saw. When it whipped, coming back, this part is the stable part. Whipping this over left and right creates a stress and strain, two directions on this one. And that's where you get your fractures. That's the rattling that way. Let's let it play.
Researchers found fallen debris and several cracks.
Yeah, if we look at it, we can see that the top movement is higher there, and the fourth floor is the one it's rotating upon. Look. Let's look at
And
it.
several cracks, with weaknesses concentrated around where the pillars meet the
Where the pillars.
girders supporting the floor.
Right, where the pillars meet the girders supporting the floor. So you saw those girders I set up. In this case, it would be these girders here. And it says weakness, and that's your connection. That gusset plate idea, like I said. It's just wagging the tail. Let's look at this. If they got anything on the floor here.
NIED aims to use its
Oh yeah, this is very interesting. This part here. This is let's let it play.
research to implement disaster prevention measures in public institutions and increase preparedness for future earthquakes. The simulation took place at the eDefense three-dimensional full-scale earthquake testing facility in Kobe, which investigates why and how structures collapse.
Let's go back to
The prevention measure.
that's the one I wanted right there. All right, so let's look at this one. As this shakes left and right, this gets a little more stable. This acts like a little compression test on this area here, and it fractures it and fractures it. And the more rotations more cycles it has, the more it starts compressing this area here, fracturing it to hell. The top of this head of that, well, it's not quite the head of the column, but there's the floor there. And that's where it's decided to pick on. Let's look at that again. The development of it. I think we've met the development. I think it's maxed out on the development in this video, but let's see.
NIED aims.
There it is. So we just saw this one come into there. It's really like a compression failure, a crush test. Like if you could turn this on its side, this would be the load, and this is another load from that direction. And this is the shear break across the two planes. It's being compressed in this zone here. That's why down here looks good. Yet these are moving at different rates because they have the shear panels, if you would, the wall, the ceiling, the floor tied down to them here. Multiple places makes it a lot more stable. And incidentally, I don't see the other, the one coming back towards us. This might be an outside wall. Well, that's kind of weird. Then that would be the cantilever. No, it's just a weird one in part of the building. So it's anchored down into the beam here. So that makes this beam more stable. This beam more stable because it's tied into the floor. And then it becomes a point where it can crush, as we observe. And now it's starting to be able to, as it rocks, it's able to even pull apart. Because you can see the gaps open up, and then of course they close when there we go. And so then we get this compression, spalling going on here. And that's coming off. They mark these X2, X2, X2. I don't know what that means, obviously.
Disaster prevention measures in public institutions and increase preparedness for future earthquakes.
Let's watch it at 4 then. He said 4 shakes the most. So 1, 2, 3, 4th floor. 4 is the one that fails the most. So if we zone it, this would be okay. And we'll zone it down here. And these two are more rigid, and that's the rotating point, if you will. The axis. Let's watch it.
Researchers found fallen debris in several cracks, with weaknesses concentrated around where the pillars.
Okay, so I'm going to take care of that speed. And when you look at that collapse and the earthquake there, it's just that they're older buildings. They weren't designed with the newer thinking of earthquake technologies where you're trying to lock down things, and some of them may have some hydraulics in them to help them take the sway. Steel buildings are inherently better because of their connections, their moment connections to really lock things in. And I've really done a lot of research on that with shake tables. And it seems like the more steel, it's really not predictable on where it's going to collapse until you watch quite a few of them. So I sort of end the video with this one. This is the steel shake table. The shake table they put of the steel structure, trying to get certification for it, for I think California. It passed. They shake the hell out of it up to a 7 point something earthquake, and it doesn't kill anybody. It doesn't collapse. It buckles. Where would it buckle? You guys can pause the video and try to guess. As it shakes, the buckling is here. Okay, it's not the same. It's one of them, not all 4. But one of them buckles, and that's considered a failure. But people can still get out. So there's got no mass tune dampers here or any isolation pads. There's nothing like that on this. It's there. I'm sorry. They initially when they were shaking, their connection there, their bolt down connection was done. But I think when they bolted it down, I think I called foul on the way they bolted it down. Something they did when they did that, I called foul on it. I forget what it was. And did they weld it? I forget what it was. Okay. So this structure like this can take the shaking. Now you can retrofit concrete buildings with what referred to as a fuse systems that can take some cross bracing. It can take a licking, and will bend, will deform, and that will take some of the during an earthquake. Will take a lot of the stresses. Of course, you got the water tanks that people put on top of a building. I'm going to end the video because, look, those buildings are very old. Their construction appears to lack a lot of rebar. I didn't see any rebar piles of mess, but clearly had rebar in there. But you know, the earthquake was excessive. It's on the fault line. You got multiple reasons why it's more likely to fail than not. Now the thing is, will they come back and put new construction codes in it, sort of similar to California, with its repeated earthquakes, or will they go with the Japanese style? It's expensive, it's costly, and I like the Japanese style. So what does it tell you about the 10 floors? You know, 10 floors, the fourth floor failed. So it almost tells you, hey, you don't want to live on the fourth floor of that design if you knew that design was going to be repeated. I mean, how many buyers, though, are actually looking at the construction of their building? It also might tell you that, okay, they took that up to a 7 point something or earthquake there. You might want to consider living in a stronger, robust, newer building with earthquake design built into it, and figure out how they tested it, and go with where it failed. I find out where it failed, maybe in their extrapolations, because remember that's a model. And so you would think that they would want to do in earthquake zones, maybe 9-story buildings would behave much stronger, or maybe maybe that one floor off the top won't do much. Maybe that 10th floor should be added with a liquid tank up there. Of all things, maybe a swimming pool to help tune the buildings in. End the video. Bye.